Okay, welcome back to the second session for today. This second session will feature presentations from the Ministry of Energy and Natural Resources, presentation from TÜNAŞ, and then we will break into a panel discussion. So with that, let me introduce to you the chairperson for this session, is Mr. Ismaël Yabda. Ismaël, the floor is yours.
Good morning, everyone. So thanks for this introduction. So maybe to give a small introduction for myself and another introduction. So I have 17 years in nuclear industry experience. So I was past experience with the Tractable Engineering company, which is the owner's engineering, architect engineering of the plant in Belgium. And I was also involved in Turkish projects. So for the Sinop one, as the head of the licensing team to develop and build and operate 4 Atmea 1 nuclear power plant in the Sinop. So unfortunately this project stopped, but we will maybe discuss quite quickly about this experience as well. And last experience with the business development activities as well for the group. So, and now I'm active much more on independent consultants on the nuclear energy. So today, as mentioned by Zaf, so this second part of the presentation will focus much more on specific experience project beyond the ACUU one. So what happened after? I mean, ACUU is there, as we mentioned. There is several activities that were performed, several projects. We are now start construction of the unit 1, 2, 3, and the other are following up. We understood from several panelists just before that there is a huge need of experience, and we know that the experience needed in the beginning of any program is not the same as the second one. So there is the engineering, as mentioned by Mr. Yusuf Bey, so the engineering during the siting activities. You have then the construction, so you have also a lot of licensing activity to get the construction license, discuss with the PSAR, Preliminary Safety Assessment Report, then to select and procure this plant, so you need other type of activities and resources. Then you build, and during the construction of the plant, you need other activities, as mentioned by NITED and the Turkish Standard Institute. You need inspection, people there to inspect the construction. Where are we? I mean, to be sure that the safety standards are met, which is the most important item you need to focus when you build a nuclear power plant. And now, of course, what was mentioned, there is the operation and commissioning that will be needed. So, of course, it's other experience. So, after this ACUU project, I will give a small introduction before I'm giving the floor to some speakers, as we mentioned, from TÜNAŞ and from the Ministry of Energy. So, the most important now is to see, okay, there is this ACUU project. The Sinop project starts. What can be the lesson learned to build the next step of the nuclear program in Turkey? So as we mentioned, the Sinop project starts with the licensing activities for the site characterization. So after site selection, site characterization, which were finalized by TÜNAŞ. And now they are in the step of, okay, we need now to select the technology to go on and to build a nuclear power plant on the Sinop site. We can mention about the TRES project, which is much more close to the Bulgarian border. So at that time, the activity, or what we can say that the activity are focusing now on site investigation, site selection, site investigation, and of course discussion with the future operator or future technology vendor that will build, and we will see what will be the model, build, operate, or build, transfer, whatever it will be. So it's still in discussion between Turkey and Chinese side. What I need also to mention is that those experiences from Sinop and the ACUU project are quite important because there are lessons learned. I can mention several ones. About the Sinop one, it was a first of kind technology. That objective was to build in Turkey. So it means that Turkey developed some specific capabilities to start the licensing of a plant which was built never else. I mean, it was a first of a kind for Turkey. So it means that either from the Turkish side, the Turkish company involved in the project, the safety authorities that need to review the assessment made by the technology provider, is really a lesson learned. So So that's really I think that it's an important point to mention. The second is about the site characterization. So activities and I would say capabilities of the Turkish side to develop site characterization, performance site characterization, which was performed either for the AKUYU, but of course more involvement of the Turkish institution or Turkish companies for the SINOP project. We need also to learn about the lesson learned from the financial issues. So of course we know that for the SINOP project, the technology and the technical feasibility went well, and finally the objective was met to say that, okay, this site is really suitable to build a nuclear power plant, but the issue was much more on the financial one, to say what should be the business model to make this project a success. So definitely it's also one lesson learned from this. The second, and we will discuss it during the panel, what about the standards and the involvement of the Turkish company? So definitely it's a lesson learned from AKUYU, maybe more than from SINOP. But the Turkish company were involved for the procurement and to supply equipment for the AKUYU project. But we know that it's also specific to the licensing basis of that project. And those projects really rely more on Russian standards. So what about now the lesson learned from this experience to involve the supply chain, the Turkish supply chain on the Russian standards, and to jump now on another maybe project that will probably be Russian if it is Russia to build in SINOP, maybe more US approach or US standards if it is the Korean that will build maybe in the second side. And what about also the Chinese? Even if the third side, we know that the Chinese are also much more focusing on US regulatory association standards. And what about also the talents? So we know that Turkey developed resources. So now, how to use these resources that was developed, that increase their capabilities to work on the Turkish program, the Turkish project. What about also quickly about the experience of Turkey in the research reactor? Because maybe it was not really mentioned, but Turkey built and operated a research reactor in Istanbul, in the Küçükçekmece area. So unfortunately it was stopped. But this was also an experience of Turkey in the research reactors. This will also need to be used as an asset and experience for development of a nuclear program. And this jump, and maybe make the link also with the SMR, because as we will mention, and I think several presentations will follow, but the SMR, we know that it is power which is reduced compared to the large nuclear power plant. So it means that the approach to make a development of SMR, we can say that it's much more close to a development of research reactor than a large nuclear power plant. You don't have the same power outputs, so it means you don't have the same licensing and safety issue. So you have to apply some graded approach in terms of development. And I can mention also, which is a great initiative related to the SMR. So we know that there is this, I think it was mentioned, the MOU signed between TÜNAŞ and Rolls-Royce for the development of a potential SMR in Turkey. But also related to the asset of Turkey for SMRs. We know that there are several developments, especially for thorium salt, molten salt reactor, because we know that Turkey has a lot of thorium mining. So it means that this should be also used as an asset to select maybe the technology for the SMR. So as a conclusion, we can say that Turkey really has a lot of experience in assets, but now it's how to use this lesson learned and assets to go further, to participate in this objective of triple the nuclear energy in the world by 2050. So thank you very much for your attention. So now I will give the floor related to the first participant. So I will welcome Mr. Hakan, please, from the Ministry.
esteemed Minister, esteemed General Directors, and distinguished guests from all over the world. My name is Hakan Hatipoğlu. I have been working for Minister of Energy since 2011, and more than 13 years I have been mainly involving in localization, industrial involvement efforts of Turkey. And today I would like to give brief information about our targets and major activities, actual localization ratios for main items in Akkuyu, prominent capabilities of Turkish companies, and conclusion with our lessons learned from Akkuyu NPP project. First topic is targets and major activities, and by the way, I will pass between the chapters with photos from some touristic locations of Turkey. I think they will be attractive for our foreign guests. Our first target, of course, in Akkuyu project is to reach at least $6.5 billion localization amount. And we have already met this target in the second quarter of this year. And our plan is to revise this target by the end of this year. And our negotiations with Russian party is ongoing. Also, we will arrange a workshop for update this target on next November. And of course, for the other projects, our aim is to increase this localization amount unit by unit, project by project. And after gaining experience in domestic projects, will be key for Turkish industry to become an exporter country for abroad projects. Also, we have already companies that export their services and products to abroad, from France to Hungary to Egypt. In the past, Germany, there are exporter Turkish companies. And what is our ultimate goal for the long term? Our ultimate goal is to become a self-reliance country in operation, maintenance, and fuel fabrication, both for large-scale reactors and SMRs, within maybe 30 years up to 2050s. And before starting to explain the activities, also I would like to introduce key stakeholders, key participants of the Akkuyu NPP project. In Akkuyu project, owner and operator company is Akkuyu Nuclear Joint Stock Company, which is a Rosatom Energy International subsidiary and totally belongs to Rosatom. But main contractor, regarding localization, main contractor, EPC contractor is very important, and it is a Turkish-Russian 50-50 partnership, and this situation facilitates both localization and usage of local workforce. Also, hydrotechnical structure is a very big single package in Akkuyu project, and is entirely undertaken by another Turkish construction company, which is Cengiz company. Supplier of the primary system structure and components is Atomenergo A.Ş. Main designer is another Russian entity, Atomenergo project. And also in Akkuyu project, regarding industrial involvement, main material organization, MMO concept is very important to localize especially basic construction materials and steel structures, steel products. Besides Russian organizations such as TÜNAŞ, Prometo, and NPPs, also Turkish Standard Institute has been authorized in 2020 by Rosatom as a main material organization to certify Turkish companies. Also, I will give some details about it because it is very important for localization within this presentation. Also, before starting to explain activities, I should talk on basic challenges for every newcomer country in terms of industrial involvement. First, of course, unfamiliar codes and standards and certification according to them, because it means maybe whatever the standard, it can be ASME, it can be JASME, or it can be RCCM or GOST. After all the standard families states more or less same requirements, but it means that unfamiliar standards means that different certification mechanisms. Yes, you can have ASME stamps, but also you can have to get approval from TÜNAŞ for Russian projects. And that means additional cost, additional time, and this situation reduces your competitiveness in the tender procedures. It is not only a technical issue, but also cost. Also, contractual arrangements and related with contractual arrangements, procurement rules is an important challenge. For example, in Akkuyu project, as it is a Russian financing by Russian institutions, Rosatom Unified Industrial Procurement Standards are being used for the tenders of Akkuyu. And Rosatom Unified Industrial Procurement Standards, which is UIPS, is related with Russian public procurement standards. As all we know, public procurement standards in almost every country very strict, and not only technical issues, but also administrative details is very complex. And this is challenging for Turkish companies. Also, as a newcomer, lack of nuclear specific experience and design capability for especially safety-related equipment and other challenging issues for newcomer countries, and also in the past for Turkey. And what we have done, what we are doing to overcome these challenges. First, as Mr. Necati Yamaç stated in his speech, first one is, of course, for every newcomer country, a realistic capacity assessment, a realistic industrial capacity survey. As Ministry of Energy in 2013, we started a preliminary capacity analysis study. And after that, based on this preliminary study, EPC contractor of the Akkuyu company started a detailed audit program for Turkish industry to reveal which products can be procured in Turkey and what are the basic gaps. And after that, in order to plan, implement, and also monitor the localization activities, we established a high-level localization working group with the participation of designer atom energy operator, main EPC contractor, owner and operator, and also by the participation of Turkish Standard Institute to facilitate the localization. By means of studies of this joint working group, we specified target products, and regarding these target products, we signed a document named as Localization Plan and Roadmap. In the intergovernmental agreement, yes, we don't have any mandatory or obligatory localization article or provision, but we signed an official document, Localization Plan and Roadmap, and in this official document, we specified target products, their safety classes, their quality classes, their approximate costs, their tender dates. And regarding this document, we are specifying our priorities. Also, as I mentioned, procurement rules are complex for Turkish companies, and in order to facilitate their participations to the tender procedures, joint main EPC contractor established the Industrial Relations Office. This office helps Turkish companies to prepare themselves for the tenders. Also, as I mentioned in the third slide, main material organization concept, very important for localization in Akkuyu. Because new manufacturers have to get approval from Rosatom-approved main material organizations. In the beginning of the projects, only Russian entities were the main material organizations, such as Promete or TÜNAŞ. But in 2020, after the negotiations with Russian party, Turkish Standard Institute has been authorized as main material organization for the safety class 4 and non-classified equipment. And also in this year, on July authorization of Turkish Standard Institute has been extended by Rosatom's audit for covering Class 3 cables and Class 3 cable metal structures. Also, as Ministry of Energy, we have been organizing regular informative events and international B2B events for Turkish companies in order to inform them regarding the procurement rules of AKU and other requirements. And also I would like to talk about our future plans. Nowadays we are working on an online questionnaire system. By means of this online questionnaire system, we will collect continuously updated data from Turkish companies to show their capabilities to our potential partners, to vendor countries. By means of this online questionnaire system, we can show our exact capacity to potential vendors, and we hope that we will facilitate the feasibility studies in terms of localization with this system. We hope next year on April or May, this online supplier information system will be available on website of Ministry of Energy. And similar with almost all the supplier information systems, we will get data from companies regarding their referrals, design capabilities, human resource capacities, manufacturing and testing infrastructures, and also regarding their certifications. Also, I would like to specifically emphasize that besides preliminary capacity analysis of Ministry of Energy, also detailed audits of the main EPC contractor is very important. Because more than 200 companies within last 4 years passed the audits of the main EPC contractor. That means that these 219 companies is ready to supply goods and services to AKU nuclear power plant. And second part of the presentation is actual localization ratios for main items in AKU NPP projects. I will give some figures. For safety class 4 equipment procured by main EPC contractor, we reached approximately 48%. For basic construction materials, more than 70%. For electrical equipment, it is relatively lower than other items because, as I mentioned, certification, especially for electrical equipment, is very challenging for Turkish companies. Let me give just an example. Just for a class 4 cable, Turkish companies have to get approval from VINICA, which is Russian Cable Institute. And of course, in terms of cost, in terms of language, in terms of bureaucratic complexity in Russia, Turkish companies are facing with some challenges to get necessary certificates or approvals from Russian entities. Also, nowadays we are working on the Turkish Standard Institute has been authorized for some electrical equipment to certify in Turkey. But for now, this ratio is lower than others. But for electromechanical materials, we have reached approximately 86%. And in this slide, I would like to put specific emphasis on partnerships with experienced companies. For example, safety class 2 and 3 cables, a Turkish company, has partnership with a Russian cable company. That's why we can easily localize the class 3 and class 2 cables. For cable metal structures, a Turkish company, a Turkish manufacturer have partnerships with Schneider and Hilti, which are famous companies in the world. They have partnership with Schneider and Hilti. That's why we reach a very high ratio in electromechanical materials. For the pipeline products, we reach approximately 50%. For hydrotechnical structures, as I mentioned, it's a single package. single bid package in Akgül project, and main contractor is Cengiz company. That's why we have also reached a high ratio in a hydrotechnical structures, which is 85%. And regarding total expenditures of main EPC contractor, localization ratio is more than 70%. And what about the expenditures of the owner company, Akgül Nuclear Joint Stock Company, regarding only equipment, material, and services? As of end of the second quarter of this year, in Akgül project, total localization ratio is approximately 54%. And this number is not including salaries to be paid to Turkish citizens, taxes, or fees or other licensing costs. This is reflecting only equipment, material, and services expenditures. I am not gonna count one by one, but I would like to give some examples regarding equipment supplied by Turkish companies. Firefighting systems and equipment, automation and communication systems and equipment, water and other liquid treatment systems and equipment, electrical equipment such as board switch gears, panels, diesel electric units, cables, transformers, lifting, hoisting, and conveying mechanisms, cranes, modular contamination plants, different kinds of pumps, valves, exchangers, heating, ventilating, air conditioning units, some of the training simulators, such as firefighting training simulator, and various equipments for demineralization and desalination systems. And third part of the presentation is proven capabilities of Turkish companies. In this section, also I would like to talk about ASME certificated companies, because almost for all the world, nuclear standards have been developed from ASME standards. In France or in Japan, in the past, they took ASME and regarding their operational experiences, they have developed their own standards. And in Turkey, currently, approximately 70 Turkish companies have different kind of ASME certificates. For example, 22 Turkish companies have ASME S system for manufacturing and assembly of power boilers. 4 Turkish companies have ASME A system. 6 Turkish companies have ASME PP system. 45 Turkish company ASME U system. 16 Turkish company ASME U2 system. And also ASME has nuclear safety related certificates such as ASME NA for field installation and shop assembly for welded tubular products. One Turkish company, which is TÜNAŞ, which is sister company of the Enkan, one of the biggest construction holding and publicly traded company, Enkan. TÜNAŞ has different factories of the TÜNAŞ has these 3 ASME nuclear safety related certificates. I put a specific slide for Enkan because they are working for, it is an actual project, they are working for Hinkley Point C project, and it's a very big package. Turbinized piping, prefabrication, and also erection works in the site in England. And also, TÜNAŞ and Enkan has another big package in Hinkley Point C, which is insulation and painting works in Turbine Island. And they are using their ASME nuclear safety specific related certificates for this job. Also in the past, as you see on the table, they have previous experiences in Germany and in France, specific nuclear experiences they have. Also, I would like to talk about API certificated companies, American Petroleum Institute certificated companies, because in Turkey, almost in all the refineries, in all the pipelines, in all the petrochemical facilities, we are using ASME, API or EN norms. And especially API certificated and ASME certificated companies experienced in oil and gas industry, petrochemical industry, and they can easily adapt to nuclear industry. And they can easily manufacture pressurized equipment such as vessels, tanks, valves, pumps, pipes, and supports without any major, any expensive additional investments for nuclear power plants. That means that if for the second and for the third projects, as a first step, we can, besides companies that have gained experience in AKU, we should also adopt ASME and API certificated Turkish companies to the nuclear sector, because it will not be very expensive for Turkey. Also, I would like to summarize the prominent capabilities. Electrical equipment, we can produce electrical equipment and electromechanical materials such as power and data cables, cable metal structures, switch gears and transformers with international standards incompatible with IEC, IEEE. Also, we have worldwide companies in construction sector, construction of industrial facilities and hydrotechnical structures. We can produce mechanical and electromechanical equipments incompatible with international codes and standards. We have valuable experiences in software sector, especially for simulation coming from aviation and defense sectors. We can adapt these experiences to the nuclear industry. Also, materials, almost all the materials for hydrotechnical structures, such as high-density polyethylene pipes or fittings, can be procured from Turkey. Almost all the basic construction materials, such as steel structures, bars, or other steel products, can be procured from Turkey. And as I mentioned, we have already exported companies to Hungary, France, Germany, and Egypt, for example. Also, I would like to put another specific emphasis on NÜTET company, because they are exporting their engineering services, inspection services to Yabda, to Hungary, Pakistan, and which is a state-owned company, has established mainly serving for Turkish Nuclear Regulatory Authority, and they have gained experience from AKU Nuclear NPP, and now, because by means of their experience, thanks to their experience coming from AKU, they are selling their engineering services, inspection services to PAKSH project. And last part, conclusion with our lessons learned from AKU project. Before our plans, I would like to repeat again our ultimate goal. Our ultimate goal to become a self-reliant country in operation, maintenance, and fuel fabrication, both for large-scale and small modular reactors. To become a manufacturing country. Also, as all of us know, AKU is a build-own-operate project and entirely belongs to the Russian party. But for the next and third projects, our aim is to incorporate Türkiye Nükleer Enerji Corporation, which is TÜNAŞ, to the owner and or operator as operator in the project, and use public-private partnership model with the participation of TÜNAŞ. And also, as I mentioned, in the intergovernmental agreement, there is nothing in the IGA of the AKU regarding localization. But for the other projects, our aim is to determine targets for each unit, gradual targets. And we are expecting supplier development program with joint developed by EPC contractor and vendor. Otherwise, if we will not determine targets or if we will not put specific articles to intergovernmental agreements, then it will not be complete. Also, commonly used international standards with which local industry is familiar is very important to increase the localization. As I mentioned, we have already ASME or API certificate companies. We should not request them additional certification, especially for non-nuclear items or safety class 4 items. Also, we are expecting determination of localizable products to be supplied directly from local industry without international competition. To sum up, I would like to give some general ideas regarding nuclear energy. Why nuclear energy is important for Turkey. Nuclear energy is not an electricity generation option, but also an important tool to create a leverage effect for domestic industry and qualified employment, as well as technological development. Nuclear energy is not only base load, but also clean. Also, nuclear energy is a cross-section, is a multidisciplinary area. Developments in the nuclear industry will also reflect on other high-value sectors such as machinery, conventional power plants, maritime and petrochemical industry. And the Republic of Turkey is ready to share our experience and knowledge with newcomer countries on industry involvement and localization. And last year we celebrated 100th anniversary of the foundation of Republic of Turkey, and yesterday was the 101st anniversary of the foundation of our republic. As of today, Turkey is the 70th largest economy in the world. Our GDP has exceeded $1 trillion as of last year, and also our annual export exceeded $250 billion. And regarding that, government of Turkey considers nuclear energy as a driving force, as one of the locomotive sector to improve economic growth and prosperity of the Turkish citizens, such as Republic of Korea did in 1970s. Thank you very much.
Thank you very much, Mr. Hakan, for this insightful and really comprehensive, result in lesson learned. So unfortunately, I know I have, and I'm sure the audience have several questions for Hakan, but due to lack of question, we will jump directly to the next session. But please, take your time during the breaks to ask all your questions when needed, and I'm sure that also maybe during the sum up of the event, we will also maybe try to address some specific questions on the several topics addressed so far. Thank you very much again, Mr. Hakan. So I will ask now Mr. Ahmet from TÜNAŞ to join the floor, please. So he's the program manager for the localization and supply chain within TÜNAŞ. Thank you.
Distinguished Minister and representatives from the Ministry, esteemed General Directors and members of our industry, honored guests, ladies and gentlemen. It is a pleasure to welcome you all here today. Thank you for joining us as we explore local industry involvement in NPP projects in Turkey. I'm Ahmet, Program Manager with TÜNAŞ, and my colleague Cihangir could not make the event today due to a last-minute occasion. This is why I'm here with you. I start all my presentations with a short sentence, a key takeaway. So, if I can continue where Mr. Hakan Bey just left. A rising tide lifts all boats, and a rising NPP lifts all industries. So, regarding the agenda today, it's very brief actually. Let's have a look. Now, I will briefly give our company profile. Our CEO already talked about our company, so very short. Then inform you on our supply development program. Executing this will result in the establishment of the nuclear industry platform that I will mention. Following, I will mention the supply development handbook, and finally the findings of our supply business in the field. So, our CEO already talked about this, as I mentioned, just for the new ones, or for the ones in the running. TÜNAŞ is a state-owned company, and the responsibilities of TÜNAŞ rest on three pillars: managing new-built nuclear projects, establishment of the here-required specific expertise, and enabling the build-up of a local nuclear industry and infrastructure. We had more than 80 expert staff. I think in November we'll be reaching 100 now. So, TÜNAŞ Supply Development Program. Before going to Supply Development Program, let me just mention our projects very briefly. The National Energy Plan of Turkey foresees a total of 20 gigawatts nuclear installed capacity by 2053. 15 gigawatts of this installed capacity is expected to be covered by three large-scale NPP projects, namely Akkuyu, which is about to be commissioned, and the planned SNOP and Tratium projects, as Ismaël also mentioned. The SMRs are also anticipated to fill the remaining 5 gigawatts gap of this capacity until 2053. The programs and projects we pursue in the company are selected with great care, because our ultimate goal is to become a knowledgeable investor in the nuclear energy field and to accumulate the necessary expertise in this area, so benefiting both ourselves and our partners. For this purpose, development and infrastructure plays an important role. Our company is developing the nuclear industry platform as a part of the supply development program that I mentioned. To understand this program, we need to answer some basic questions. Where do we want to go? To define the strategy and target products was necessary. This step gives us the localization priorities. The products, goods, and services, PGS, required to build an NPP are divided by us in three categories: build, optimize, and maximize. Build means where there is a big room for development, but we see them as strategic benefits for Turkey, so it should be pursued. And maximize is where production is already there, and we see attainable economic benefits with just small improvements. So, where are we now? We are in the industry capacity assessment phase. Since 2012, there are many works on supply development and localization being pursued by our Ministry of Energy and Natural Resources, which build a quite solid base. And since 2024, this year, we increased the pace visiting the suppliers systematically and recording their capabilities in a holistic manner. I will mention this briefly, what I mentioned this. So we have set the target, know where to go, and we understand our current status. So third step is doing the gap analysis, along with developing business plans together with our suppliers. And finally, how do we develop the capabilities of our suppliers? By implementing these business plans on the supplier side, that they will invest in their infrastructure and human capital of the ecosystem. And secondly, government, who will enable legislations and incentives to suppliers in order to facilitate and speed up their programs and projects. So, now we defined the program's goal, but how do we achieve it? With the help of an entity that we call Nuclear Industry Platform. Establishment of this platform by bringing together equipment and service providers in the nuclear supply chain in Turkey that will build a strong local ecosystem in line with the localization priorities. So what this will platform do? 6 fundamental tasks. Act as a single voice for local supply chain, drive industry capacity assessment, perform supply qualification and monitoring, execute the supply development handbook, facilitate work package tenders and supply engagement, and lastly, track localization targets set by Union. So, I said the platform will execute the supply development handbook. For developing this handbook, the enormous number of products, goods and services necessary for the construction operation of an NPP will be compiled within several hundreds of mutually exclusive work packages. For each of these work packages, the handbook is expected to contain the technical specifications, tentative budget and schedule for the specific work package, the applicable incentive mechanisms, if any apply, and the business model and business plan templates that will be utilized in these tenders. So we introduced very briefly the program, the industrial platform, and the handbook. Now let's have a look at what's currently being done. In this phase, today, we are performing the technical supply visits. It started with supply eligibility process. Eligible suppliers were identified in this process. The supplier pool, namely the eligible supply list, establishes the basis of suppliers that will be considered for participating in the program. Then comes the supplier scoring process. This scoring will ensure eliminating the low-performing risk from suppliers to decrease the supply dependent risks. What we have in the end is the shortlisted suppliers. This acts as a tool, a decision support mechanism, if I may say so, for supplier acceptance or rejection decisions. So, using the supplier pool, long listing that we have, over 100 suppliers are selected in more than 25 equipment groups to be visited in 2024. Over 25 experts perform the visits and evaluations, undertain main subjects such as management systems and governance, design, engineering and production, and workforce development. So, after visiting and taking notes, reporting comes in. Then we prepare the evaluation reports, compile best practices, and suggestions on areas with room for improvement for our suppliers. So I would like to share our initial findings from our field visits, fresh from home. Efforts are being carried out with great diligence by our suppliers to ensure compliance with national and international norms and standards. Hakan just gave very good examples for them, such as ISO, ASME, API, and IC. So, corporate structuring and strategic management efforts are being implemented. Efforts in digitalization, lean manufacturing, and knowledge management are being carried out to utilize more efficiently what we are producing and doing. And sustainability initiatives are being followed. Digital tracking and control systems are actively used, and necessary investments are being made to comply with carbon border adjustment regulations that are about to arrive in 2015, 2025, 2026. So, focusing on decarbonization and achieving net zero carbon emissions target. Opportunities for collaboration, national and international, are aimed at diversifying the customer portfolio, and investments are being made by the suppliers. Special emphasis is placed on increasing overseas market share, namely exports. Investments in human resources are being made to meet workforce needs. Many companies effectively and efficiently manage their supply chains, while some are working on improvements in this area. And there is a strong emphasis also by our supplier side on investments in design, engineering, and R&D. So, new investments are being made or planned to enhance capacity and capabilities. And if I may say so, most importantly, all of our suppliers are eager to support the Turkish NPP projects as long as the necessary support is provided by all key stakeholders. So our duty as a TÜNAŞ here is to find a common ground serving both our national strategy and priorities on one hand, and our suppliers' corporate goals and strategies on the other hand. By establishing this common ground, we can drive successful outcomes for Turkish nuclear power plant projects in the future, and today, together with the local Turkish supply ecosystem. Bringing all stakeholders around the table is crucial for maximizing this potential of the initiatives. Thank you for your time.
Yeah, thank you very much, Ahmet Bey. So as we said, we are very short in time. I will maybe ask Hakan Bey also to join. We can maybe select one question from the audience related to this topic, because it's quite, together this topic is quite important as well. And I know that some in the audience may have. So may I ask only one who will take only one, please, from the audience. So I don't know if someone can share the mic to someone, if someone has a specific question related to the localization approach or strategy in Turkey, related also to the industrial involvement of the Turkish companies, and what's the program in terms of involving also external organizations in the supply chain. So from the audience, if there is one question. It seems people want to eat. I think so. So I will thank you again. Thank you very much for this insight. So thank you. Now we will jump to another topic which is also quite important. It's related to human resource, as we said, and the capabilities and skills to develop a nuclear program. So I will ask a panel to join, please. So Mrs. Bayhere Gültepe, President from the Women in Nuclear, please. Thank you very much to join. Dr. Cemil Kocar, Chairperson of Nuclear Engineering in Hatipoğlu University. And also Mr. Necati Kaya from TÜNAŞ, Head of Engineering Director. Thank you. Is it working? Okay, perfect. Okay, thank you very much, and thank you for your patience for installation of this panel. So, as we mentioned, the objective is to discuss about human resources, and I will have several questions before the panel. I know that some of you may have a specific presentation. We will try maybe to manage to answer the questions, and I'm sure that we can cover all the topics with the few questions that we have. So I would like to ask the first question to Mr. Necati Kayabe. So we discussed about the capabilities during the first presentation, capabilities needed to develop such kind of nuclear program, and of course, as we said, resources. So a specific point was mentioned during the first session was related to a specific matrix that you developed to identify what are the capabilities needed. Can you maybe elaborate a little bit on this, please?
Actually, first, maybe we should talk about the manpower requirement during the power plant programs. And as we know that manpower needs for their projects vary significantly, ranging from a couple of thousands for the smaller nuclear programs to up to 200,000 for larger self-sufficient countries like China, Korea, Russia. Considering all these factors and need at TÜNAŞ, we recognize the importance of developing our own plan, and we started competency development plan since 2021. And there are 5 pillars we focused on for the competency development. And these are, for the competency development, our approach was to academic development of our personnel and the international collaboration, certification programs, mentoring and peer training, and on-the-job training as well. So in our vision, as you may see, we emphasize that competency development is one of our target, our goal. So at the beginning, we have developed a normative skill matrix, which is defining all necessary workforce for any nuclear power program, starting from the planning up to decommissioning. And in that study, you can find all necessary skills, knowledge, and the necessary quantity of the workforce. And then we prepared a knowledge pool, skills and knowledge pool to define how which knowledges should we have, for our personnel. And we make a gap analysis, and we define all the necessary workforce for the TÜNAŞ, and after that gap analysis, we define which competencies will be internalized and which can be supplied from our partners. So last year we completed our competency development plan, and we defined all necessary quantity of the personnel and the needed competency levels, as and skills and knowledge and experience. And nowadays, we are trying to meet that gaps, by trainings, by international collaboration, by education, abroad. So it is very new, and we will see, how we are successful in the future. Thank you.
Thank you very much, Hatipoğlu. Maybe to jump to that, I would ask Mr. Jamil. So we just mentioned that there is these gaps or maybe skills necessary to develop and be successful in this program. What is the current situation, in the universities in Turkey, and maybe especially in your university in Hatipoğlu?
Thank you. First, I would like to tell a few words about me. So I'm a professor of nuclear engineering. So I was working in this department since 2007. So since 2017, I have been working as a head of department. Actually, the history of our department is very long. It established in 1978. More than 40 years ago, we established this department, and our colleagues established that department. So the first BS students enrolled in 1982. Since that time, we graduated more than 600 students with a nuclear engineer title. Actually, in the past, before the AKU project, our graduates had some struggles while finding jobs, especially in Turkey. But due to the nature of nuclear engineering education, maybe you know that there are various disciplines involved in the curricula of the nuclear engineering department. They could find jobs in different fields, such as application of radiation in medical science, or application of, for example, computational fluid dynamics in different fields, and so on. So they work in different fields. And some of our students also prefer to go abroad, especially in the United States. Currently, if I am not mistaken, around 100 graduates from our department currently live in the United States and working in national labs of the United States, such as Idaho National Lab, Argonne National Lab. Also, some are graduates working in universities of the United States. So, what changed after the AKU project? So, the first step we have taken. So we made some changes in our curriculum. Currently we are offering some technical elective courses, especially specialized to BVER technology. So if students prefer to study in this topic, they can pick up that courses. Also, we did one more thing. Maybe you know that the reactor physics or thermodynamics or reactor or nuclear fuel cycle will not change from place to place or from country to country too much. I mean, especially the basic things. The neutron diffuse everywhere same. So what we did? So while choosing, for example, homework problems or while choosing projects, we specifically focus to VVR technology instead of, for example, let's say Western type PWR or BWR. We are offering that kind of homeworks, exam questions, or projects to our students. Also, we, with the help of our Minister of Energy, also we started to initiate another step for the AKU project. So it has a long story. We are trying to develop a joint Master of Science program with some Russian universities, including MIFI, Moscow Energy and Physics Institute, also some other universities from different cities, such as from Leningrad. But here we have some challenges, especially due to highly regulated higher education in Turkey. I mean, it's centrally regulated. So because of that reason, we have some practical problems. For example, I can say that in Russia, they have different type of courses localized to a few weeks or semester-long courses. But in Turkey, due to regulations, our courses should be semester-long. Another point maybe I can raise is that, for example, AKU company strictly wants 2-year Master of Science program. So, I mean, the Master of Science should be completed within 2 years, but according to our regulations, the student can extend to 3 or 4 years in Turkey. So, now we are trying to overcome those difficulties. And then, also our experience is telling that the nuclear engineering education should be harmonized with the country nuclear technologies. So this is also another important thing. And then everybody here knows that in a nuclear power plant project, from site selection up to decommissioning, different fields involved in this project. I mean, for example, geological science, computer science, chemical engineering, mechanical engineering, civil engineering, and so on. The nuclear engineering only a small portion of it. So also other engineering fields or other science fields also should be aligned with the project. Our experience, also I think international experience is telling that the other fields such as mechanical, civil and chemical and so on, first they complete their formal education with a PhD degree. After that, we recommend that by providing short courses or maybe focused trainings, they can work in a nuclear power plant project, because before starting their work, I think they should know some fundamentals of nuclear energy and some fundamentals of especially radiation. Thank you.
Thank you very much, Mr. Jagan. I will ask now, Ms. Göktepe, what is your thought about, the current situation in human resource, especially in the nuclear field in Turkey, and maybe to jump to this women organization in Turkey, which is a movement which started in several countries, and especially the objective was to involve more and more women in the nuclear field, not necessarily only nuclear, it's normally an objective in several engineering fields. What is your thought about the situation, especially maybe in Turkey, and maybe the objective that you see?
Thank you, Mr. Chairman. Ladies and gentlemen, distinguished speaker, it's a really great pleasure to be here to address you all as President of Women in Nuclear. In fact, when Yabda invited me to this platform, I said this is a business platform, so you should introduce me with my title as the CEO of Türkiye Enerji, only Turkish national nuclear consultancy company established by Turkish scientists raised in Turkey by the Turkish Atomic Energy Authority, Çekmece Nuclear Research Center. Here I used to Magic Word Çekmece Nuclear Research Center. I'm very pleased that you mentioned the importance of research center and research reactor. So Jaffa told me that it is more important that you talk as a leader in women in nuclear, and I'm proud with this title, of course. I'm leading 194 wonderful women in Turkey. They're all highly educated in nuclear energy or applications, and some of our members are here, Esra and Sezin, they are here. And so what we do, we are a good communication group. Why women in nuclear become very important in the world and in the nuclear industry? As you know, nuclear industry went through different stages. If you let me, I have very interesting slides here, colorful slides, but because of the shortage of time, our chairman doesn't let us to show the presentations. Okay. Nuclear industry went through different stages through the history. And recently I was in Uzbekistan, and the Russian speaker said that this year is very important because we are celebrating the 17th anniversary of first nuclear power plant, commercial nuclear power plant, which is, as you know, obvious. So when I was showing the audience the development of nuclear industry, starting from early ages and 70s, where I do talks about the development of nuclear energy in different countries, I suddenly realized that and changed the style of my talk. I said this graph reflects kind of my life. Why? Because you said, for example, your experience in nuclear industry for 17 years, and some speakers talk about 13 years and 10 years. If I say that my experience in nuclear started in the late 60s, starting at 70s, as a student in United Kingdom, so probably you will think that I'm a dinosaur. So I don't want to raise this, but it is really true. How I started this field when I was a young student, high school, I was selected to be trained specially, and then when I had my talks in Russia and other countries, I talked to young girls, addressing them, because there are very important programs in the world, encouraging young people, boys and girls, to go into high-tech industry and nuclear. So they are, we have to motivate them. So they are using leaders and, some leaders to talk and motivate them. During one of my talks, I was telling them, the young girls, how I started this nuclear career. They wanted to hear my life story. I said, I was taken to an interesting place for a technical visit when I was in high school. And I saw something and I fell in love. It was my first love. And it was sort of very, interested actions in the audience. I said, if I see the presentation at the back, it was the blue radiation, Cherenkov radiation. I saw it, nuclear swimming pool, nuclear pool. It's an open type reactor. Then it was like magic. I was so impressed. Then I was sent to United Kingdom to study nuclear engineering. Then came back to Czech Nuclear Research Center. This is how my own career started. Then it is usually going through the development of nuclear industry. In almost year 2000 and before, world nuclear leaders, they all get together in London, and the World Nuclear Association. Now we have a woman leader. It was previously Uranium Institute when I was a student. So I used to go there for presentations often. And there, all the leaders, they discussed problems or priority problems of nuclear industry. Those years, as you know, nuclear technology started with obelisk. They grew and grew. Then there was a time after the oil shocks, people started thinking that it was the end of nuclear power. There were no new orders, and there was a strong public reactions. And there was this 3 Mile Island, Chernobyl, and there was a decay in the public trust in nuclear, and many difficult times. But through all these times, I had some experience in the research work that we done through the Turkish Atomic Energy Authority. In those years, leaders of nuclear industry in London, in one of the meetings in London in year 2000, I never forget, they said, okay, we sort of underestimate the public view in nuclear, because we thought that we are the big industry, no matter what happens, we will carry on. And I can remember one of the American leaders saying that, oh, the goddamn public, we thought, well, what is the public? We are a big industry, and then he said, we were wrong. Public reaction was very important, and the leaders of the nuclear industry, they realized that the communication with public was necessary. It became the priority. They put large, big programs or PR programs, and if I had time, I could talk more about it. And then they also decided that women were the best in communicating with public. So there we started Women in Nuclear Global Organization. I became a member and originated in Turkey. Now, what we do, I always have this declaration, my main comments. women empowerment organization benefit everybody. And if there is, if in societies there are women, if there are no women highly educated in nuclear science, not only nuclear science and technology, societies are incomplete. These are main two comments. And recently I added up another point, and I can easily say that due to my experience in the Eurasian countries, if the nuclear industry does not have highly qualified women in nuclear safety and security and communication and risk combination, a certain percentage in their organization, nuclear industry is incomplete. So we believe the power of women. As you know, in the world is going through a new stage, and if I could answer my graphs, and we passed through several stages now. After COVID, nuclear power become the worldwide interest. As the number of nuclear power and interest in nuclear power is increasing, silent power of women is also increasing, because world needs women in fighting the climate change. In particular, we all know that. And women, by nature, have certain qualities, like we care so much for our families, for our natural resources, for environment. So, women in nuclear, I always encourage my colleagues, we are the best communicators, we are the best environmentalists. And we, women in nuclear, are highly educated in these areas. Women leaders can be best safety and security leaders, and they can be best risk communicators. We are the best, some of the best and top experts in disaster management and risk management, as well as environmental protection. With my colleagues in the Nuclear Research Center, while we were working, we suddenly decided to do lake protection project, and we become very leaders in the region to protect the Çekmece Lake and other lakes region. Then we took over the big IAEA project, Marine Environmental Assessment of Black Sea, after post-Chernobyl, one of the biggest projects. So it was when Turkey, which we have the longest coast of Black Sea, Bulgaria, Romania, Ukraine, Russian Federation, and Georgia. It was a very hard work, but we managed the best analysis and public relation program as well. The story goes on, and through this project, I received the Black Sea Medal from the United Nations. It was not my work, but it was additional work. So we, as women in nuclear, we are so interested in what is going on in the world, and we are really caring for the development of nuclear power technology, plus safety and security and all the other problems. If I have one more minute, I would like to perhaps this afternoon can show you. As women in Turkey, we propose a STEM project, because for Turkey, we are going very well because of our new project and new projects online. But for me, basic education is very important, university education, so I congratulate our friends from Hacettepe. But while doing this, they do this basic education, we need training of students and the research facilities, like Çekmece Nuclear Research Center. So my recommendation to here, we have our leaders in the government, Necati Bey and Yusuf Bey and Hakan and all. I think for me, more important than the second nuclear power station in Turkey, second nuclear research reactor is really very important. So, Women in Nuclear is a global organization in 145 countries and more than 35,000 people. We get together from time to time. These days, our annual meeting is in Mexico. I couldn't go there because I had other programs, but I was connected online on 28th. And you know what Mariano Grossi said? I was a diplomat in Vienna, so I know him very well. In addressing our group, he said, within the next decade, 1 million people are joining the nuclear industry. So I keep thinking, okay, new nuclear power plants newcomers are coming, and 1 million people will be joining the nuclear arena. So how we are going to treat them, how we are going to train them, it's really big. You cannot train nuclear workers or leaders like this. It's not easy. Looking at me, I have 70 years behind me, 50 years, very deep, very hard work behind me. So training is very important. And one of the main problem of nuclear industry is real scientists and best technicians are retiring. Nuclear industry is getting old, retiring. So young people are many young people we must motivate. How we motivate them, how we can educate in the best way is one of the key areas of nuclear industry. So we propose STEM project as a woman in nuclear Turkey. I sort of become the part of International Council for the Development and Support of Women in High Technology. This group is supported by Rosatom. And suddenly, women from 16 countries, we get together and we propose some projects, and we are preparing a white book. And for Turkey, I propose a STEM project for young girls, and I even have a symbol, 4-flower model, 4 yapraklı yonca, science, technology, engineering and mathematics. We have nice symbols for girls. In each country, 4-flower has special meanings and some similar meanings. They mean love, luck, and some luck and fortune. And we have this model, and we have all the activities with the international group. I very much hope to implement these activities in my own country if our administrators and if our leaders support us. Supporting women in nuclear is very important for the stronger and better future of nuclear industry.
Indeed, and I can also maybe mention that each time during the history that a big technology advancement was made, women were more involved, especially during the fourth, as we said at that time, the fourth system. Each time there is a big industrial evolution, we need more manpower and more people to be involved. But to be honest, maybe I will come back to one specific thing, and I will jump to the other panelists. In 2015, I was also quite astonished to see in the Turkish nuclear, university, the Turkish university in general, but in the nuclear department, to see number of women already there compared to Belgium. So
yes, more women in university academicians. Yes.
Is it something that it's quite new, and I can maybe jump to Jim to see it's quite new people already involved, in engineering, but also on that topic?
Actually, I don't know figures or numbers in other countries, but I can say the situation in Turkey, since 1982, our graduates is more than 600 as a nuclear engineer. Almost 20% of them are women. In the past, actually, the situation was bad. Around less percent, 10%. Currently, the number of women students are increasing who prefer to study in nuclear engineering. Currently, I can say that 13% or 25, more than 25%. So, in Turkey, as a department, we do not have any right to choose or pick up the students. First, the students after the high school enter an exam, a central exam, and then after that they sorted according to their points, and then they choose the department he or she wants to study. So because of that reason, there is a chance that all the students can be male or all the students can be female, but current situation is around that one. For the women, underrepresented groups, and for the talented students, I think the best option to increase their number in the nuclear engineering, the best option is to offer scholarships. So I think scholarships will work, and then the number of women, number of talented students will increase after offering scholarships for BS degree in nuclear engineering.
Thank you very much for your answer. And maybe to come back maybe to the general figures on human resources. As you mentioned, Turkey has a nuclear program, so you have some specific objectives to meet. How, maybe I will jump maybe to negative way, how is made, this expectation in terms of talent and capabilities and people, and how is maybe the partnership made between the companies that are involved in the program and the universities, maybe from your point of view?
Actually, it is essential to engage with the project partners, for the development of the human resource development. So, in our case, there are some scholarship programs conducted by our partners, and each year around 15 people has been selected by us and sent to the Chinese universities, like Tsinghua University and Harbin University for their postgraduate degrees. And I can say that more than half of my team from engineering department are the students coming from that programs. So these programs are very important, not only for the education point of view, but also they provide some internship programs, in parallel with that education program. So that's why I can emphasize that early collaboration with the project partners is very important. Again, you don't sign any contract for the construction of the NPPs. During your negotiation, such kind of programs can be established, and we can benefit from their experiences, and we can send our people, for the competency development. And also, it is very important nuclearization of the other disciplines. Of course, nuclear engineers are very vital, in our projects, but on the other hand, this is a multidisciplinary project, and we are employing engineers and from other disciplines, like electrical engineering, computer engineering, chemical engineering, physicists, So such kind of master educations, are also very important, for us for nuclearization of the other disciplines. We all know that nuclear projects are very complex projects, and multidisciplinary teams need to work together and solve complex problems. During the development, during the negotiation of the projects, and also construction of the projects. So that's why we have already conducted such kind of scholarship program and utilization of our employees, and on-the-job training is also very important. So with our partners, we conducted several, let's say, programs, and also international organization is a vital part of our competency development. And thanks to WANO, World Association of Nuclear Operators, and the European Utility Requirement Association, we take part in their studies, and we get benefit from their activities. And thanks to them, they are very open for sharing their experiences and knowledge transfer. Thank you.
Thank you. Related to that, which is also quite important, what you said, all of you, is related. Okay, you identify the gaps, you identify the capabilities, you try to update maybe the curriculum inside the university to fit and to meet the, let's say, the program and the national program expectation. From the other hand, based on the specific technology that you select, you send maybe people to specific universities outside. I will come back maybe also to what you said. It's going to be related to that. And it's a question to all the panel. So, as soon as you send people maybe follow a specific curriculum outside, maybe in Russia, maybe in Korea, maybe in China. We know that, and maybe it's an example of what happened in Turkey in '58. People were trained, the AKU project did not start, and a lot of maybe experienced people left Turkey to follow the cursus or curriculum, or maybe a specific journey outside. What can be done now, except maybe, as you mentioned, that we need to start a nuclear program soon? What are the all other leverage that can be done, to keep those talents that will go, be trained maybe outside, come back? I mean, a general question, and I believe you, maybe all of you to give your idea about that, what specific Turkey.
I can start. I can speak about nuclear engineering part, actually. So, as we know, the other disciplines are also involved, so I don't know what will be their fate. So, I think the nuclear engineers has a chance because of their curriculum, I mean, the courses which they took are from different disciplines, such as they know, let's say, heat transfer, they know fluid mechanics, they know also radiation, the interaction of radiation with matter, and so on. Also, they will have some good capabilities, especially using softwares, computational simulation, and so on. Because of that reason, even if they cannot find a job in the nuclear field, still they have a chance to find job in other fields, including the application of, especially application of radiation in other fields such as medicine, industry, and so on. Also, they can find in other fields such as they can use the practical education which they acquire during the 4-year education. So, I think that will be the case for the nuclear engineers. Thank you.
Thank you. Adana, Mr. Necati Bey, what's your thought about this situation?
Actually, in Turkey, there are very good universities, and as I said, we just not focus on nuclear engineers. There are lots of different engineering departments, and there are very high qualified universities, providing the needed resources to us. For example, we are in pre-project phase, let's say, and we are conducting side activities for the time being, and we have very well trained, educated people, from our universities. I mean, for example, for seismic studies, we employed people, graduates from Turkish universities. So, but of course, there's still there are a gap, we need to fill in, universities and the industry should be more close and talk to each other and understand their needs, and evolve accordingly, So, but anyhow, we are very happy with our employees and graduates from Turkey as well. But for the nuclearization, we have an opportunity, to send our people to the abroad for their postgraduate degrees, That's my point. Thank you.
Thank you. Thank you.
Of course, I'd like to comment on this. Brain power can be a very serious problem, of course. Very highly educated people need good facilities and good jobs to improve their talent and experience. If we cannot hold them, there is no way out. On the other hand, it needs new strategic plans in Turkey, especially now. Turkey is becoming an international country with the AKU project, and second and third projects are online. This is a very important development in our history. But parallel to this program, we need to start looking at the research side of it. All these activities must be supported by national research and development. This is vital. Otherwise, just having projects with foreign companies, no matter how big they are, how strong they are, is the different side of the story. But at the same time, we must try to improve our national capacities and research and development, again, to support our this dynamic nuclear power program. So one of the best ways is to open research centers or to rehabilitate them, try some new research facilities for university students. You said they practice online training job.
On the job.
Online.
On the job training.
On job training. To where do you do this? You cannot do training in the power plants. You can just take them to visit and to see. But when I was a student in UK, there was a research reactor in my university, University of London, Queen Mary College and Imperial College. And we were also, our teachers were famous teachers, Sir John Hill and Robert Kahn, father of metallurgy. They took us to power plants, which was under construction, Magnus plant. So, with parallel to theoretical lesson, having a good student and capacity of new people, you have to train them on job training. It is very important to have research facilities. So, and now I was so impressed with the Uzbekistan program very shortly. They started very fast SMR program. SMRs are, as you said, almost like research reactors, small, 65 megawatts. They are building 6 Russian-based, and it will also help our capacity if we want to become a hub to develop SMRs that you mentioned, to having a research facilities, national research facilities with research reactor, other research facilities. And also, we all talk about the university education, but how Russians and Americans and other developed countries in nuclear power go, they want to encourage people, young people, to enter into nuclear, to choose the nuclear industry. In those countries, it is not so difficult because they have a big nuclear industry and big nuclear chain facilities, starting from mining to fuel, yellow cake production to fuel fabrication, then manufacturing of components for reactors and operating reactors, operating research reactors, icebreakers, submarines, everything. And it's the same in the United States and other European countries, in China. But how do you keep these students in Turkey with their interest in the jobs for nuclear? Nuclear is always very attractive and unique and mysterious field. If you ask me, I always encourage people to go. But if they think about the jobs, we must really make a quick decision for the second nuclear power plant, but with the national contribution, with the sort of technology transfer model, not the same model. Probably our people are working on these projects. And also the encouragement of young people should start from high level, high school. And why? Because once they go to university, they already go into university, they choose their science, technology, engineering field. But encouraging young people while they are in high school for science, technology, engineering, mathematics is very important. Now there's a big project in the US, I heard. Their nuclear industry now, new young generation. Nuclear employees want highly educated and skilled people to work in the nuclear industry and facilities. But how they are going to get it? Not all of them have nuclear engineering education. So they start from high schools and technical colleges. They provide new safety courses and encourage girls and boys to choose these STEM fields from the high school level, then carry on. Because as you said, nuclear industry needs, or they are going to expect with this increase in the deployment of nuclear power all over the world, 1 million people will be added to the nuclear workforce. So how we are going to educate them? I'm a safety and security consultant. I keep thinking, my goodness, it's a very ambitious word, and how we are going to make them first-class workers. It's a challenge for our administrators and for Yabda and Yusuf Bey and others. How in our country, how we are going to achieve this is really hard and challenging work.
Thank you.
But the future is very bright for nuclear power.
Yeah, indeed. So maybe to summarize quite quickly, I will retain from this discussion that first we need all the workforce and manpower needed to develop this program. We need to increase the collaboration still between the companies and the universities to be sure that we have the necessary capabilities. We need to develop quickly the program so the people that were trained will stay in the country, especially considering that we have an international revival in nuclear all over the world. So I think it's an issue and maybe a challenge for all the countries to see how they retain their talents, considering that nuclear program is reviving in every country. So, and maybe important of the research, I will mention and maybe summarize, that's important also to keep, especially for the research. Yeah, indeed. Thank you very much.